the definite integral is just, I want to show you what we missed out on yesterday. And then kind of refine your thinking on this. There are just a couple things to address. So, remember, what does calculate the integral actually mean geometrically?
Are you recording this? You know we can't see now.
I was telling my wife last night, I'm like, Erin, I'm kind of worn out from this week. I still have to teach tomorrow.
You know, it would have been better.
4 hours of
figure
calculus
that out.
to teach tomorrow.
Hits
Sure you
you
want to
days, he's
attend?
like,
Okay, let's try that again.
got caught that early.
And now the people that are on my YouTube channel subscriber list are like, deleted. Oh, never mind. Not there that many. Okay, so
6.
this means calculate what? Geometrically, if I were to explain what this means geometrically, what would it be?
0 to 5.
0 to 5 of the function
3 minus x.
3 minus x. Okay, good. It's an area calculation. It's just a line, right? Geometrically, what shapes are we looking at here? Yeah, they're triangles, right? So what are the areas of these triangles? Ready, set, go. Since you're calculus. Right, 1/2 base times height. So this would be 9/2. Fractions are friends. Okay, it's like, shut up, it's Friday. And what about this triangle? 2 times 2 is 4, 2, 2. Okay, here's what, now geometrically, do we ever have negative areas?
No.
We don't, okay. But again, like yesterday, if we're in calculus, this is actually going to be a negative number because it is below the x-axis. It's showing the location. So your total area here is 9/2 minus 4/2, which is 9/2. Okay. Yeah, that's what this. Right. In reality, what we should be saying is it's the area between the curve and the x-axis. Okay, so if you really want to get specific. No, it's plus. So you add areas to get the total, right? So this would be 9/2 plus -2, which is the same as subtract.
Okay, so would you do it the other way?
The other way.
Like you
Oh.
can
Yeah.
with the antiderivative?
The other way.
You plug in the 5 once you get the antiderivative, and then plug in the 0, and then subtract the 5 number minus the 0 number?
Yeah, so what is the antiderivative? Okay, there's no variables, so just put an x on it. Minus, and then add 1 and divide by 2. Evaluated from 0 to 5. Please be very conscious again about writing the notation correctly. Okay. So we have 3 times 5 minus 5 squared over 2. That's squared minus 0. Right?
Yeah.
So that's 0. What do we get? 15 minus... Oh, look at that. Isn't that something? They match. The calculus automatically does the signed area for you. Be careful there. Good. Let me throw something at you then. It's not going to be an eraser, I promise. Can you calculate? Absolute value. How are we going to do with that? Yes, we do. What would it look like? It's positive. Is it ever going to be negative? No, so it's actually going to bounce back up here. Right? So we are calculating 9 over 2 is the same. What's this area now? It's positive 2. Right? So our absolute value area is 14 over 2? 13 over 2, because I could add. Correct? So, geometrically, not very easy to deal with. When you hit the x-axis, go back up, right? So if you got something, just, this is not for today, you're not going to see this, but let's call that x squared minus 2, right? What is the absolute value of that look like? Cool. Follows? Follows? What happens here?
And over the x-axis.
That's what that's just like. Yeah, it never goes negative. Everything is just above the x-axis. So you're not going to have to calculate this today, but it comes in once in a while. Question. How can I calculate this algebraically now? Right? Any ideas? Do you know how to calculate an absolute value and a derivative? Okay, so we have to actually split it into two problems. 3 is the dividing line, right? That's where it turns. So we need to go from 0 to 3 and add from 3 to 5. Zero to 3 is the original, correct? So we can just pencil that in as is. So this is no different. Aside the inner limits. How can I represent this as a function? Do I want to find the equation of that line? Not really. I don't. You can. Here's the easy way. It's just the opposite. So the original function is a negative. What's a negative times a negative? That gives you the positive. So, again, not very hard. You just have to know what to do. And then you have two integrals to calculate the same way we did the first one. If you're given one anti-derivative, you can calculate it geometrically, or you will be given a calculator for alpha. It's not, you will not do that algebraically this year, or maybe if you're in DC school, so no algebra for that one, for now. Okay. All right, we good? Got it? Okay, I want to show you, I showed you that yesterday, kind of bounced around. Yeah, I kind of mixed up yesterday and today. I apologize. That's what happens when I'm winging. Are there any others that you want me to show you that you saw on the homework that might be questionable? I already showed you what a sine and cosine integral. Yeah. Like that? We don't do those operators. If you, like I said, if you get those on the AP exam, it will be a calculator-friendly problem. And all you have to do is calculate with the calculator. I'm not going to show you that yet, because I want you to do it by hand. Let's do something different than 0. Is that what you're asking? We cannot do this geometrically because it's a curve, correct? There's no exact way to do it. So let's see, an antiderivative of e to the x is? Yeah. And that is? And you're done. Nothing you can do with it. Right? You might run into something like this. Okay. Yeah, what is it's going to give you actually a numeric answer now, right? Yeah. So same antiderivative, you just have different limits. So we have e to the ln 5 minus e to the ln 2, which is 5 minus 2, which is 3. Okay, so you just have to know your natural log rules, your e and natural log rules.
Okay, so with the top one, you just have to find out the actual value. That's fine.
No, they'll probably give you that as an answer on a multiple choice. And if it's a free response, you just show that. No worries. Now that's an exact answer, and mathematicians love exact answers. Perfect people, right? You can roll your eyes through. If you can estimate that at all, it's not an exact answer. So I think that's it. Try and handle the rest as long as you understand it. Oh. What if, here's something you might run into. If that is true, calculate the value of so the antiderivative of f of x from 0 to 2, or the integral from 0 to 2 of f of x is 6. What is the integral from 0 to 2 of 3 times f of x? Yeah, it's 18. 3 times 6.
Oh my goodness.
Did you forget the 2x on the other side?
There's always something, isn't there? No, it's there.
What is
Yeah, no, so you have an integral. By the way, that's called a spelling error on the exam. Go figure, right? That's serious. F of x is 6 units squared. 3 times f of x is 3 times 6, so 18. Right.
So where's your new function?
It's just a new function. Instead of saying, well, I only have 1 f of x here, I'm saying I have 3 of them. What's the new value? What about it? That's just telling you that you're integrating with respect to the x. These should always match. If they don't match, you're in trouble. But you guys will not have that issue this year. Okay. Is that it? I think you have all the homework, right? Yeah. You want me to write it down again? Okay.
Was it like 3 or 2? I know you're deadline.
There you go.
Hey, have you even done that?
Got one.
Don't you have to take like a thing of my people are going close?
I already asked and told people.
I'm going.
I told you guys if you want to go and tell me. Okay, couple notes about tomorrow. Bus leaves at 7.
7. You forgot it was a real thing.
Orders on the bus, you will probably have no mercy if you tend to leave on time.
Yeah.
Anybody doing alternate transport? You need to get that
I already got it signed by Porter.
Yeah, what?
Okay.
It's got a time of number.
Order's fine. You know, anybody not going?
Been on that bus?
You're not going to be talking about the packets that happen. Anybody else? Okay. Tomorrow at 7 a.m. out front. We should be back at 2:30 or so. Maybe 3. It's
Depends on how fast you drive your own car.
You said 2:30.
I am.
Oh, I gotta check out my date. I got plans
Here are
Saturday.
the sessions. Oh, it's full extended desktop, man.
Like crap.